This question involves limiting reagents, but also use of solutions and concentration. So 5.6 grams of magnesium reacts with 25 centimetre cubed of 0.1 m, or 0.1 molar, which means moles per decimetre cubed, of HCl. What mass of hydrogen gas is produced? So first of all, we start by writing out an equation. Magnesium plus hydrochloric acid makes magnesium chloride. Don't forget how to do formulae. Mg2 plus, Cl minus, so we need 2 chlorides. And hydrogen, not forgetting gases, diatomic. Okay, balancing. 2 in front of the HCl. I have a mass of magnesium, can't do anything with masses, and I have a volume and concentration of my solution. I don't know which is in excess and which is limiting, so let's work that out. Number of moles of magnesium is equal to the mass divided by the relative atomic mass, which for magnesium is 24. Gives me an answer of 0.233 moles. Number of moles of HCl. I don't have a mass, I have a volume and a concentration. And if we look back to our equation that we've used previously, to get number of moles, I will need to rearrange this. I will need to do concentration times volume divided by 1,000. So number of moles is concentration times by volume divided by 1,000. Because my volume is given to me in centimetre cubed, that's where the divide by 1,000 comes from. 0.1 times by 25 divided by 1,000 gives me an answer of 0.0025, or what was given to me in my calculator, 2.5 times 10 to the minus 3 moles. So, if all the magnesium was to react, looking at my molar ratio, I would need twice the number of moles of HCl. So 0.233 moles of magnesium times by 2, 0.466 moles. I would need 0.466 moles of HCl. Do I have that? No. Therefore, magnesium is in excess, HCl is limiting. So because I want to work out the mass of hydrogen produced in this reaction, I need to work out my number of moles. I don't use my magnesium because not all of it reacts. I use the number of moles of HCl, which was 0.0025. So the ratio, is 2 to 1. Therefore, the number of moles of hydrogen is equal to the number of moles of HCl, which I've worked out here, divided by 2. So 2.5 times 10 to the minus 3 divided by 2 is 1.25 times 10 to the minus 3 moles. And then I can convert this to a mass of H2. Mass of H2 is the number of moles, which must be used to using this equation by now, times by the relative molecular mass. Molecular atomic mass of hydrogen is 1. 2 of them, so it's 1 times 2. So I get my original answer back. 2.5 times 10 to the minus 3 grams. Very little, but that's what we would probably expect, as hydrogen is a very light gas. We could then go back on to work out how much magnesium was left over. The number of moles of HCl reacts. I can work out moles of magnesium reacting 2.5 times 10 to the minus 3 divided by 2, 1.25 times 10 to the minus 3 moles. Convert that into a mass of magnesium, 1.25 times 10 to the minus 3 times 24, 0.03 grams. So this is how much mass of magnesium was actually used. I started off at the beginning with 5.6 grams. So I haven't used very much of it. I have left over 5.6 minus 0.03, which is equal to 5.5